Now that we know a little bit about lists, I thought I would use this video to introduce you to loops, and in particular for loops. And if we have time, we might do other types of loops. But before we even do that, I want to introduce you to a built-in Python function called range. When I say built-in, it means it comes with Python. And it's really a way to generate lists that have integers that increment. So for example, if I just say range of 6, it makes a list. It generates a list from 0 through 5. So it's 6 elements up to, but not including 6. If I wanted to include 6, I would have to do range of 7. And then I go all the way up to, but not including 7, but I get 6 in there. If I want to have 1 through 6, if I don't want to have that 0 there, I could do range starting at 1 and including 1 up to, but not including 7. So the first item here will be included. The last item will not be included. And then we get, there we go. We get 1, 2, 3, 4, 5, 6. And what's cool about these integrated development environments, these IDEs, this PyScripter that I'm running, is that when I type in a function that it recognizes, it actually will tell me a little bit something about that function in case you forget it. So I don't know if you can read this here, but it says range, start, stop, step. So you can also, if you want, tell it how much to. So right now the default is to increment by 1 each time, but it says, hey, I could tell you to increment by a different number. So let's say you have a range. Say you start at 0, 0. You want to go up to 8. And I want to go up by 2 instead of 1. So then I went 0, 2, 4, 6. And I should have said it more precisely. Up to, but not including 8. The upper part of the range, you don't include it. So it goes up to that, and it increments it by 2. So you could do it like that. Or you could even, so maybe you want to start at 3. And you want to go up to, but not including, I don't know, let me do up to, but not including 31. And you want to go up by steps of 3. So there you go. They went up to step by 3, up to, but not including 31. So it can generate a whole bunch of lists. And the reason why this is useful is because we can use these inside of loops. And so the first type of loop I'm going to introduce you to is a for loop. So this was the interpreter down here. Here I'm going to actually write a program. So this program is really just to show you what a for loop does. So I could say for I, and I is this variable that's often used in for loops, in iterative loops. And iterative means you keep doing something over and over again. For I in, and let me just do a simple one, in range, and I'm just going to say 5, range of 5. So this will generate a list 0, 1, 2, 3, 4. So for I in range 5, and this colon says, now we're going to have a subclause of what to do on each of those iterations. Let's just print out what I is. And so before we even see what this is going to do, let's just think about it. It's saying set each time we go through this loop, for each of the things in the range, make I refer to them. And then each of those loops is going to refer to a different one, and you want to print it out. So let's just try this out. So let me save this program. And now let me run it. So there you go. What it did is it created a loop. So each time it goes through the loop, it assigns I to a different element in this list. As you remember, this list was 0, 1, 2, 3, and 4. And so, did I say 0, 1, 2, 3, 4, 5 before? No, it's 0, 1, 2, 3, 4, up to, but not including 5. And so each time you go through the loop, it goes through each of those items, and this program really just says print out that I. So the first time we go to the loop, I is 0, so it prints it out. Then it prints out 1, then it prints at 2, then it prints at 3, then it prints a 4. So it just keeps going through it that many times. If we said this was for a range, I don't know, 10. Now let's run this program. You'll see it'll print 1 through 9. It'll print 1 through 9 or I should say 0 through 9, because that's the first element in this list. But you could do more interesting things. Let's say you wanted to take the sum of 0 through 9. So what you could do is you could define another variable here, sum. So before I do anything, the sum is just going to be 0. And then what you could say is each time you go through the loop, why don't you add to sum? Why don't you define sum to be the previous sum plus what I is in this part of the loop? And just so that we can keep track of it, I then want to print the sum. Now let's see what this thing does. So let's try it out. So let me save it, and then let me let me run it. So there you go. Each time we went through the loop. So the first time we went to the loop, sum is 0. Sum is 0 and I is 0. You add them together. You print the sum. You get 0. The next time we go through the loop, I is 1. We add that to the previous sum, which was 0. Print it. You get 1. Then the next time through the loop, I is now going to be 2. Add that to the previous sum. 2 plus 1, you get 3. Next time through the loop, I is 3. You add that to the previous sum. You get 6. So the sum of all of the numbers, 0 through 9, is 45. So just that's actually a kind of a useful program. But just to make the point a little bit clearer, let me actually walk you through this on my little drawing tablet. So let me paste it. Let me paste my code that I just wrote up here. And let's just think about what this is doing. So we have a couple of variables here. We start off with this variable sum. That is set to 0. So sum, and there's two ways to visualize variables. A common way to visualize it, and this isn't necessarily wrong, this is sometimes an easier way to think about it, is to view them as buckets. But in Python, the really correct way, and you saw why that's important with lists, is to view them as referring to something. So if you view them as buckets, you can kind of say, OK, from the get-go, the number in the sum bucket is 0. But the reality is that the variable sum is now referring to the numeric literal, the actual number 0 sitting in memory someplace. Now we enter into the for loop. And what the for loop says is, let's iteratively assign I to each of the elements in the list generated by range of 10. So just to be clear, if we call this right over here range of 10, this will generate a list that looks like this. So it will generate a list 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Up to but not including 10. This is 10 elements right over here. And then we go into the for loop. So the first time we go through the for loop, and let me write it. So I'll think about it two different ways. So I'll think about it in the bucket way. So we have this variable I that can actually only be used inside of this clause. We'll talk about more about scope, or where a variable could use. But this I variable is only good inside of this clause. The sum variable, the way I've defined it, I can use it anywhere, outside of the clause or inside of it, because it was defined outside of the clause. So you have your I. So this is if you think of it as a bucket. And so through the first iteration, I is assigned to this first item over here. So I is going to be 0. The reality, the better way to think about it, is I is actually referring to this first element our first time through the loop. And then we go through the loop, and it says sum plus I. Well, sum is 0 and I is 0. You add them together, you get 0. So sum is still going to be 0, or still referring to 0. And then it prints the sum out. So then this line right over here, it prints sum. It says, OK, the sum right now is let me do it in blue. It's just 0, and it printed it out. Then it goes back to the for loop and says, look, are there any more elements that I can assign I to? Well, sure there are. There's all of these that we have to go through. So then it makes I the next element in the sequence. So now I is going to be the next element in the sequence. Or another way to think about it is in the I bucket, if you want to view them as buckets, I is now set equal to 1. And now we run this again. And we say, OK, sum is 0 plus I. I is 1. So sum is now going to refer to 1. So sum is now going to refer to 1. Or another way to think about it is sum is now going to refer to 1. And when you print sum, it'll now print 1. Then the for loop will say, all right, are there any more elements in this list right over here to assign I to? Well, sure there are. There's all of these others. So let me keep going. So I can now be equal to, or can refer to 2. So if you think of it as a bucket, I is now 2. Or you say I is now referring to 2. And you can ignore these right over here. And we go through the loop again. Sum is now 1. 1 plus I is now 2. 1 plus 2 is 3. So sum is now going to be 3 this time through the loop. So sum is now referring to 3. You print sum, you get 3. And you keep going all the way. I is going to keep referring to as we go through the loop will still keep going as there's more things that I can that I can refer to, as if we can keep incrementing I to these other values over here. And eventually, I is going to be 9. We're going to evaluate this. And the for loop says, hey, is there anything left in this list that I can be? And you're like, no, there isn't anything left in this list. And then the loop is going to be done. And we'll break out to it, and the program will stop. And that's exactly what we saw happening. That's exactly what we saw happening when we ran the program over here.